Hello. Today I'm going to talk to you guys specifically about motion vectors. So we've been talking about motion now for the entire year. We want to just add in the idea of a vector to it. And so now you have a little bit of a background on how to add vectors and how they can't be added just directly as you did before. So now we can kind of expand and put the two things together. So the vector side and the motion side can kind of come together, and I think you'll see how it works. All right, so let's imagine for a minute that I have an object that starts at this position. And so what I would see if I had a reference point here is that that position vector looks like this. It's not easy to draw a straight line on the computer screen like that, but I do my best. So that position vector looks like that right there. That's x sub 1. That's its position against away from that reference point. So you could measure it up until this point. We've been measuring it in a number of meters. You could say it starts off at 2 meters away from the reference point, then it ends up some other place. Then you know it moved. You get the idea. So we're doing that same kind of thing. Okay, so that is a vector, right? Because it is some distance away from the reference point, and it is in a certain direction away from the reference point. So then later on, we come back to the object here, and we see that the same object is now located all the way over here. Not great. There you go. It is what it is. I'm going to try it one more time here because I don't feel good about that. So that's pretty close. There we go. So now it has this x sub 2 position right there. And you can see that it also is a vector because it has a distance away, and it also has a direction in which we're measuring that distance. And so my question for you is, this is a position vector, this is a position vector. How do I know what the displacement is? And I need to know what that displacement is because I need to know what the displacement over time is to be able to figure out the velocity. And so let's take a look at it here. Apparently, here we go. Let's see if I can get a different color in here. Ooh, so many colors to choose from. I'm going to pick green. Okay, pretty lame, I know. So here's my question. What's the displacement? Remember, displacement is the change in the position. And in this case, we're going to say it's the change in the position vectors. And so you could see that the object started at this location, ended at that location. And so if I draw this out, I'm going to try to draw it as straight as I can here. It's about as good as I'm going to get on the screen here. That is the displacement vector right there. You can see that it started here and it ended there, and that's how much it changed its position. And that's what this means, right? Delta x is change in position or displacement. So that's the displacement vector. The object moved from here to there, so it has a distance of that much motion, and it is moving from here to there, so it's in that direction. So hopefully that makes sense, that we can use that as a descriptor of the motion of the object. Now, the cool thing is we can take, if we want to find the velocity of the object, so coming over here, we could go and find the velocity of the object. Let's see here, navy, that'll be okay. So the velocity of the object, which is a v vector as well, just like that, is going to be equal to the change in the position vector, or the displacement vector, if you wish, divided by the time. Is time a vector? Of course not. Does it make sense to say 5 seconds in the north direction or up? No, of course it doesn't. So our velocity vector is just the displacement vector divided by each individual unit of time. And so let's say that to go from the start to the end here, it takes the object, let's say 5 seconds. Well, let's make it 4 just because it's easier for me to draw. So let's say 4 seconds is our delta t right there. So what does that mean? That means that in the first second, it moved 1/4 of the way over in that direction. And then for the second second, it moved 1/4 of the way over. And then the third second, it moved 1/4 of the way over. And then the fourth second, it moved 1/4 of the way over, like so. So that I can take that whole displacement vector and divide it by the number of seconds that it took, and that should tell me what the velocity vector looks like. So there's our velocity vector right there. So the object has this velocity each second. So you can see this is what the velocity looks like for the first second, this is what the velocity looks like for the second, for the third second, and for the fourth second. So just by dividing it by the time, we can figure out what the velocity vector is. Now, you're probably thinking, is that an average or an instantaneous? And the answer, of course, is that we don't really know exactly what happened between the start and the end. We just know that after 4 seconds, the object that was here is now over there. And so really this is an average velocity there. And notice I'm not using the word speed because speed implies that there's no direction that we're worried about. Finally, so if I have velocity vectors, and let's say you have an object that's moving down a ramp here. So I'm going to change my pen again to black. So here's our ramp. Okay. All right, and so we have an object at the top there. And then later on, we look at the object and it's down here. So initially, it may have a velocity that looks like this. So v sub 1 vector looks like that. V sub 2 vector, though, looks like this. Now that makes sense, right? Because when an object rolls down a ramp, it changes its velocity, right? It gets faster and faster and faster. And so we should see the velocity vectors change. So let's say it took 1 second to change that much. Well, if I take a look at this v sub 1 vector, it looks like this. Right? So I've just tried to redraw that over here. And if I take a look at the v sub 2 vector, it looks like this. Right there. So how much did it change? Well, if I know that it took 1 second to change, I should see that the object is changing its velocity in this direction by that much. And if that took 1 second, then that's what we call the acceleration. So that's our average acceleration vector. So the acceleration vector is equal to the change in the velocity vector. So how much did the velocity change? It started at this, and now it's at that, and I think you can see it must have increased its velocity by that much, divided by the amount of time that it takes to change. And so this is our acceleration. This is where we get it, right there. They're related. Hopefully that makes sense. We don't do a lot with acceleration vectors in class, I have to admit, other than the acceleration vector, which we use for the acceleration due to gravity, because we do a lot with gravitation. But we do, it is important for you to understand what these things actually mean. And so hopefully this makes a little bit more sense. If you have any questions, please let me know. Thanks.